today. All right, so we're going to talk about naming, and I have some resources I think are really helpful. So if we go down to resources for exam 1, this is really the only folder that's labeled resources that's relevant to you this week. And it's over chapters 1 through 3. We're finishing chapter 2 with naming. And I have a naming flowchart. That one's handwritten. I should probably make that go away. All right, I'm going to pull up the PDF. I'm a chemist, so of course I'm going to decompose it into a flowchart. Come on, somebody. Yes, a flowchart for naming. We only learn how to name binary compounds, which means A, B. A, B could be 2 different elements or could be 2 different ions. So our first step in naming, we have basically 2 sets of rules for naming. We have rules for ionic compounds, and then we have a separate set of rules for covalent. I'm going to start with covalent. Is it ionic or covalent? Because we have 2 separate rules, that's the first question we need to ask. If it's ionic, it follows one set of rules. If it's covalent, it follows the other set of rules. But it's pretty easy to figure it out. All we want to know is, does it have a metal or a polyatomic ion? If it has an ion, it's ionic. Okay, so that's what I'm asking. Does it have a metal or a polyatomic ion? Metal, you just look at the periodic table. Does it start with anybody but this? Does it start with, here we go. Does it start with any of these guys? Does the formula start with any of these? Except for hydrogen, right? Hydrogen's not lit up, okay. If it starts with anyone to the left of that staircase of the metalloids, anything to the left and below, these guys, it's an ionic compound. Metals, for our class, form ionic compounds. They lose their electrons to form cations. And because they're positive, they partner with something negative. Okay, so that's my first question. Maybe I don't start with a metal. How do I know there's a polyatomic ion? Well, you don't have them memorized yet, so I'm going to tell you a really easy, quick and dirty trick. If you have more than 2 elements in the formula, and it's a naming question for our class, it has to have a polyatomic. If it's binary, it has 2 parts, an A and a B. If one of those is a polyatomic ion, there's more than 1 element written. So you know if you have more than 2 elements, symbols, in the formula, it has to be a polyatomic ion. So quick and dirty way, just for now, before you have them all memorized by tomorrow, how to tell if there's a polyatomic ion. Okay, if it has a metal or more than 2 elements, it's ionic. If it doesn't, where did it go? Where did it go? If it has a metal, where did it go? Oh, I made it go away. PowerPoint, there it is. Okay, if it has a metal or a polyatomic ion, if it has a metal or more than 2 elements, it's ionic compound. So if it's a yes, does it have a metal or a polyatomic ion? Yes, it's ionic. If it's no, it's covalent, which we call a molecule, a covalent compound. Compound is generic, 2 or more atoms bonded together. It doesn't give you any information. Compound is generic. Ionic compound tells you these are charged particles hanging out because opposites attract. Covalent compounds tells you it's a molecule. They're sharing electrons. They have covalent bonds. So a covalent compound doesn't have any metals, and it doesn't have polyatomic ions. Okay, so I'm going to do the covalent side first because it's the nicest. This is where we use prefixes. So the rules for naming covalent are different than ionic. Covalent uses prefixes. That's because they can combine in a number of different ways, right? So let's look at 2 examples that we already know. Carbon is not a metal. Oxygen is not a metal, right? Here's carbon, here's oxygen. They are both nonmetals. I only have 2 elements in the formula, so this has to be covalent. No metals, no more than 2 elements. Okay, that means prefix. That means prefix. Here it is. That means prefix. Here's the list. So this one you guys told me is called carbon monoxide. The mono means that it's a subscript, understood subscript of 1. This is carbon dioxide. You already know that. This is a subscript of 2. The prefix equals the subscript in covalent only. Ionic compounds can only combine in one way, so we don't use prefixes. But these can combine, this is the multiple proportions part, these can combine in a number of ways. They can redistribute their electrons. All right, and I have an example up here, dinitrogen pentaoxide. The only catch, and the reason I like this example is because it's in these examples, we never use mono for the first element. That's it. We don't use, and you know, because it's not called monocarbon monoxide or monocarbon dioxide, so we don't use mono even if it's a subscript of 1 or understood 1 for the first element. That's the only thing that's glitchy about this naming scheme. And I like going back to these examples because you already know that. Go back to something that you know. These are the correct names. All right, so if I have N5O10, this would be penta nitrogen. You just prefix and the name of the element for the first one, and then prefix and the name of the element with the ending "ide." Decoxide. I think I would just skip the, decaoxide. I don't know. That would be a multiple choice, not a spelling. Decaoxide. Yeah, I feel like it should have decaoxide. This isn't a real molecule. I just made it up. Excuse me. Okay. The only exceptions are ones that we're not focusing on in our class, which are hydrocarbons, carbon and hydrogen compounds. So we're not going to worry about that for our class. Okay. The next set is, what if you do have a metal or polyatomic ion? That means it's an ionic compound. We don't use prefixes. This one gets a little tricky because you have to ask yourself, does it have a transition metal? So we have even more subcategories with ionic. Does it have a D block metal? What's a D block metal? These guys. I think of it as the sideways rectangle. The sideways rectangle, those are the D block or transition metals. If it has one of those, we have to say which charge. We don't memorize the preferred charges. That's too much memorization. We'll talk about it when we get to electron configuration, and it'll make a little more sense. These are always going to be cations. Always going to be cations. The way we write formulas, it's always the cation first. So, okay, yes, it's ionic. Does it have a D block or transition metal? If that's a yes, then we need Roman numerals to say what the charge is. So let's say we have this compound and this compound. So I know, like, that's a metal, it's in that sideways rectangle, so that means in the name you have to communicate what the charge is, because we don't say iron trichloride. We don't use prefixes. We write iron, if it's that D block metal, we use a Roman numeral to say what the charge is. Charge, not subscript. That's the most common mistake that people make. And then you're simply going to name the anion or the second element If it's an element, you change the ending to "ide." How do I figure out the charge of iron in the compound? Yeah, crisscross. Question? Sorry.
Yeah, could you repeat what a D block is? I was looking at my notes.
Sure. It's a transition metal. It's this sideways rectangle. And that's, right, we didn't write something on the top. Those are different possible charges. That's why we have to write in the name, we have to write the Roman numeral that is the charge. So how do we figure out the charge? We know the other component. We know the charge of chloride or chlorine in a compound is -1. That's a -1. Ionic compounds are neutral. I know that because it doesn't have a superscript charge. It's not FeCl3 + 1 or FeCl3 - 2. It doesn't have a charge, so I know the charges add up to 0. So if I have 3 -1s and it adds up to 0, what's the charge on this iron? Gotta be 3. So the name is iron, Roman numeral 3 chloride, and you would just say iron 3 chloride. Excuse me. You could do arithmetic. I use algebra. Like I'll do iron + 3 times -1 = 0. I do it like that a lot. Let's look at this one. This is iron. I don't know what the charge is yet. I know that's chloride. What's the charge of iron in this compound? 2, right? That's still a -1. It's always. If I'm writing a charge at the top, that means it's always that charge in an ionic compound. So that's 2. What if I had a metal? It's a D block metal, but then I've got this piece. This is telling me it's got 2. This has more than 2 elements. So there's a polyatomic ion. We'll pretend you already have it memorized. And you recognize that, hey, CO3, the charge is -2. That's carbonate. Here's the piece that you have to know. You have to know that is a polyatomic ion. You have to know the name is carbonate. You have to know that charge is a -2. That's going to tell you the charge of iron. If they add up to 0 and that's a -2 charge, what's the charge of iron? 2. If you add them up and you get 0, you know you've done it right. So this one is iron, Roman numeral 2, carbonate. You don't change the ending of polyatomic ions, you just write their name. Let's go back to our flow chart. What if you have just polyatomic ions? This is ammonium, and this one is nitrate. So in a compound, we just name the polyatomic ions. We don't ever change the ending. Let's say we have a metal, but it's not a transition metal, and it doesn't have a polyatomic ion. Then I just name the metal, and I name the element changing to "ide." So magnesium chloride, sodium bromide, it's not magnesium dichloride. We only use the prefixes for covalent compounds. That's the biggest mistake that people make. This one does have a polyatomic ion, so I just named the polyatomic ion. It's called nitrite. Maybe you don't remember what the charge is. You can look back through your other questions and you can see, hey, if this makes a neutral compound, and I know this, I know that sodium in a compound is +1, and this adds up to 0, you can reason your way through. It's just arithmetic, I promise, guys. It's just arithmetic. You can reason your way through that it's a -1. And maybe you need that information for another problem. So with naming, polyatomic ions are a big deal. Practicing naming, I want to show you another tool. Okay, so we go home and we go back to that folder. That's resources for exam 1. Naming practice site. This is from Khan Academy. Practice naming, practice naming, practice naming. Oh, it doesn't want me to do it. Don't be that way. Okay. So you can pick your topic. Oh, there's a Khan Academy one too. Anyways, so this is just one. You can pick your topics. Transition metals, I would pick all of these. Ions, you can do AP, university. Click all of them so you can practice. If it's a common name, if it gives you a common name like methane, don't worry about it. And then you can get started naming so you can practice. So practice. You also have homework problems that are naming problems. And here's your assignment for today. You have a quiz. That's a naming quiz. Naming problems. And it's 2 questions. It's open. Actually, I'll change this. I had it open till the end of class, but because we ran out of time, I'm going to make it open until midnight tonight. So you can do a quick naming quiz, practice before you try the quiz, work on polyatomic ions, and then tomorrow we'll start balancing reactions.